Limiting reactant. It can be said in other words, insufficient reactant or lack of reactant. Let's see the matter in detail. Suppose some amount of A is added to some amount of B. Then reaction proceeds and products will be formed. With the passage of the time, amount of A will be decreased and at the same time amount of B will be decreased. But if A is finished earlier than B, then A will be called limiting reactant and here B will be called excessive reactant. Here B will be excess of reactant and A that is finished earlier than B, this A is called limiting reactant. Definition is the reactant that is totally consumed earlier than another reactant, that reactant is called limiting reactant. Let's see some examples. In case of limiting reactant, reaction and balancing of reaction must be known. Let's consider a reaction between magnesium and oxygen. Magnesium reacts with oxygen to form magnesium oxide. Now, this reaction must be balanced. Here, 2 atoms of oxygen, here 1 atom. 2 is put here. 2 magnesium atoms, here 1. So, this is 2. Now, let's calculate amounts of these reactants. Here, 2 into gram atomic mass of magnesium is 24. So here 48 gram of magnesium. Oxygen 2 into 16. So 32 gram of magnesium. Here 2 into 24 plus 16. 80 gram of magnesium oxide. Here magnesium reacts with oxygen in this ratio. 48 gram magnesium reacts with 32 gram oxygen. Suppose 48 gram magnesium is mixed with 25 gram oxygen, then here oxygen will be finished earlier than magnesium. So in this case, oxygen will be limiting reactant and magnesium will be excessive reactant. But if 40 gram magnesium is taken to 32 gram oxygen, then magnesium is taken here 40 gram instead of 48 gram. So in this reaction, magnesium will be finished earlier than oxygen. So in this case, magnesium will be limiting reactant and oxygen will be excessive reactant. In this case oxygen and in this case magnesium will remain as remains or leftover or residue. So the reactant that is finished earlier than another reactant, that reactant is called limiting reactant. Let's see another example. Reaction between chlorine and sodium. When sodium is added to chlorine, then sodium chloride will be formed. The reaction must be balanced. Here 2 chlorine atoms, here 2, here 2. In this case 2 into sodium, gram atomic mass of sodium is 23, so it will be 46 gram sodium, and chlorine will be 2 into 35.5, it will be 71 gram chlorine, and here 2 into 23 plus 35.5, so here it will be 117 gram of sodium chloride. So here sodium and chlorine reacts with this ratio 46:71. When 46 gram sodium is mixed with suppose 60 gram chlorine, then in this case chlorine will be finished earlier than sodium. So here chlorine will be limiting reactant and sodium will be excessive reactant. But when sodium is used 40 gram instead of 46 gram, to chlorine is 71 gram, then in this case sodium will be limiting reactant and chlorine will be excessive reactant. Let's see one mathematical problem. The mathematical problem is, suppose 75 gram chlorine is mixed with 5 gram of hydrogen. Then here what is limiting reactant and which will be obtained as remains? First of all, we have to write the reaction between chlorine and hydrogen. Let's write chlorine, hydrogen, product is hydrogen chloride. The reaction must be balanced. Here 2 chlorine atoms, 2 hydrogen atoms, so here there will be 2. From this reaction we get 71 gram chlorine reacts with 2 gram hydrogen. So here which one is a limiting reactant? From this reaction we can write 71 gram chlorine needs 2 gram of hydrogen. So here 75 gram chlorine needs 2 into 75 divided by 71. It will be 2.113 gram hydrogen. So for 75 gram chlorine, required amount of hydrogen is 2.113 gram, but here this is 5 gram. So sodium is excessive reactant, then chlorine will be limiting reactant here. So in this reaction chlorine is limiting reactant and hydrogen is excessive reactant. Now we can calculate what is the amount of leftover of hydrogen. Remains of hydrogen is 5 minus 2.113. This is 2.887 gram. So in this reaction the leftover of hydrogen is 2.887 gram and limiting reactant is chlorine. Let's see another example. The reaction is between magnesium and oxygen. Suppose 4 atoms of magnesium reacts with 4 molecules of oxygen. Then here, what will be limiting reactant and what is the residue here left over? First of all, let's write the reaction between magnesium and oxygen. Magnesium plus oxygen, product is magnesium oxide. The reaction must be balanced first. Here 2, so there will be 2 here, 2 magnesium atoms, here 1, so this is 2. The question is related to atoms, 4 atoms of magnesium and 4 molecules of oxygen. Here, how many atoms of magnesium? 2 into Avogadro's number, 6.023 into 10 to the power 23. This number of atoms of magnesium here, and oxygen, number of molecules of oxygen is 1 mole oxygen, that means 6.023 into 23 molecules of oxygen. From this reaction we can say that this number of magnesium atoms react with this number of molecules of oxygen. Let's write 2 into 6.023 into 10 to the power 23. Magnesium needs 6.023 into 10 to the power 23 oxygen molecules. So here we have 4 magnesium atoms. Now 4 magnesium atoms needs how many oxygen molecules? 6.023 into 10 to the power 23 into 4 divided by number of magnesium atoms, 2 into 6.023 into 10 to the power 23. Here the number of oxygen molecules will be 2 oxygen molecules. In this question we have 4 oxygen molecules, but the required amount is 2 oxygen molecules. So this is excessive reactant, then the magnesium will be limiting reactant here. Then what is the leftover? Leftover is oxygen. Oxygen we have 4 molecules, but the required amount of oxygen is 2. So 2 oxygen molecules will remain as leftover. This is about limiting reactant. No more today. Thank you very much.